So now that we're done with order of operations, we're going to start going into looking at rational numbers and integers, and we're going to talk about what those types of numbers are. So in our journal, we're going to define those different number classifications. We're also going to draw a graphic organizer so we can keep track of them. So the first type of number I'm going to talk to you about is a natural number. A natural number is like when you were little, right? You were learning, these are our basic counting numbers. So 1, 2, 3, and so on. Those are our natural numbers. Then we have what we call whole numbers. Whole numbers are counting numbers and zero. So 0 and the counting numbers. I'm going to draw a Venn diagram so you can see how these overlap and work together. Our next number group is integers, and I do believe that based on what some of you all told me, you've talked a little bit about integers. So integers are going to be negative whole numbers well, negative and positive, whole numbers. And we're going to see where that overlaps so that we can visualize that. Then we have rational numbers. Rational numbers are going to be numbers that are fractions and decimals, that repeat or terminate, meaning they end. Because we do have fractions and decimals that don't do that. So when we do this, we're going to draw a graphic organizer to visualize these things. And I'm going to start with natural. And I'm just going to draw a box. Don't draw it too small because we've got to be able to put some stuff in it, but not too big because we're going to be drawing more boxes. So natural numbers might be like 4, 9, 10. These are natural numbers. These are regular counting numbers when you were little. Then, natural numbers are what we call a subset or a set within the whole numbers. So I'm going to write whole numbers. And notice that my natural number box is inside my whole number box. And really, the only difference between these is that whole numbers include 0. My next one is integers. Now, integers whole numbers and natural numbers are subsets of integers, meaning integers include whole numbers and natural numbers. So, but they also include negative whole numbers, so maybe -3, -21, -8. But 0 is also an integer, and 4 is an integer, and 9 is an integer, and 10 is an integer. And then finally, we have what we call rational numbers. I've run out of room at the top, so I'm going to end up drawing it down here. Rational numbers have integers, whole numbers, and natural numbers, but they also include things like 1/2, 0.45 or 4/4500, 18%, which we're going to learn you can write as a fraction and a decimal, 4/10, 3/4, 18%. All of these are nice, pretty decimals or fractions. And all of these are just rational numbers. Now, integers can be rational numbers, whole numbers can be rational numbers, natural numbers can be rational numbers as well. If it doesn't fall into these categories, we have irrational numbers. And these are not super important to us, but you need to realize they don't fall in this category. And these are going to be decimals that just go on forever, or ugly things. So like pi, the symbol pi. It's above my board, and it's 3.145192665 da 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 da. It just keeps going and going and going, and it doesn't repeat and it doesn't terminate or end. When we get into 7th grade, we talk about square root, the square root of 2. It just keeps going. Or if you're trying to take a negative square root, you can't do that. These are going to be irrational numbers. Now, we're going to focus here, and I want you to think about, I'm going to give you an analogy to kind of think about how subsets work. So, we live in San Antonio. San Antonio is in Bexar County. So we could say we also live in Bexar County, which is, San Antonio is inside of that. Bexar County and San Antonio are within Texas. We could say we live in Texas, we could say we live in Bexar County, we could say we live in San Antonio, which is also in the United States. So, Texas, Bexar County, and San Antonio is within the United States. So integers, whole numbers, and natural numbers, these are subsets of rational numbers. Okay? So that's how you can make that connection. What I'm going to have you do tonight, based on your notes, is this where do I belong? And here is another version of our diagram. And I have several different things for you here. Now, we've talked a little bit about dividing. I want you to be aware, I'm going to help you out. This is -4.875, I believe. It's been a while. This is, and remember, when you do that, you can do your cowboy horse if you don't remember. Right? So 64. 6, 0, 7, 56. That's where that came from. You can also divide your 8 ninths. Right? Remember we talked about, just as a review, cowboy horse. The cowboy goes in the hotel. The horse stays outside. So if you wanted to remember how to divide that, 8 is 72. Now this one, if you look, it's going to repeat. We're just going to get the same thing over and over and over. So we're going to put a line above it. I'm not sure if you learned about bar notation. We can talk about that in class. But I wanted to give you those as decimals so it would help you place them. So what you're going to do is you're going to look at these 1, 2, 3, 4, 5, 6, 7 different numbers, and you're going to, it may be helpful for you to place them here, and then you can put an X in the box where they go. Now, some of these are going to only have one X. So, for example, going back, if we have 1/2, it would only be a rational number. But if we have a whole number, like 10, a natural number, then we would mark that it's a whole number, it's an integer, and it's a rational number. Because some of these, because if it's a subset, it goes into all of those categories. If we have -3, well, that's an integer and a rational number. So I want you to try to place these. And then tomorrow when you come to class, we're going to look at how you did on your box, and we're going to reiterate, we're going to do a card sort to help us understand these placements better.